NASA's South Atlantic Anomaly, a deep dive into Earth's magnetic mystery. For years, NASA has been monitoring a mysterious anomaly in Earth's magnetic field, a vast region of lower magnetic intensity that stretches from South America to Southwest Africa. This enigmatic phenomenon, known as the South Atlantic Anomaly, SAA, has been a source of intrigue and concern for scientists, especially those at NASA. The SAA is often likened to a dent in Earth's magnetic field, or a pothole in space. While it doesn't directly affect life on Earth, it poses significant risks to our satellites and spacecraft that pass through it. The weakened magnetic field strength within the anomaly exposes these technological wonders to charged particles from the sun, which can cause short circuits, data loss, and even permanent damage to critical components. To put it into perspective, imagine a satellite orbiting Earth, passing through the SAA like a car driving over a pothole. The impact could cause malfunctions, glitches, or even complete system failures. That's why NASA and satellite operators must take precautions, shutting down systems before entering the anomaly zone. But why does the SAA exist, and why is it growing? The answer lies deep within the Earth's core. A swirling ocean of molten iron generates the planet's magnetic field. But the presence of a massive reservoir of dense rock, known as the African Large Low Shear Velocity Province, disrupts this process. This disturbance weakens the magnetic field in the SAA region, making it the weakest point in Earth's magnetic shield. New research has revealed that the SAA is not static, but dynamic. It's slowly drifting around and, even more remarkably, appears to be splitting into two distinct cells. This division raises questions about the future of the SAA and its impact on our planet. While the SAA's long-term implications are still unclear, it's fascinating to note that this phenomenon may not be a recent occurrence. A study suggests that the SAA may have affected Earth for millions of years, dating back to 11 million years ago. This means that the SAA might not be a precursor to a global magnetic field flip, which happens every few 100,000 years. As we continue to explore and understand the mysteries of the SAA, one thing is certain: NASA's continued monitoring of this anomaly is crucial. Even though the SAA is slow-moving, it is going through some change in morphology. So it's also important that we keep observing it by having continued missions, says geophysicist Terry Sabaka, because that's what helps us make models and predictions. With so many unanswered questions, it's exciting to think about what we might discover next about this vast magnetic oddity. What do you think? Is the SAA a cause for concern? Or is it just another fascinating feature of our planet's complex magnetic field? Share your thoughts in the comments below. Earth's magnetic shield in crisis. The growing South Atlantic Anomaly explained. Imagine this. A colossal unseen force is expanding above us, impacting America from the skies. You might not have sensed it, but high above the clouds, beyond the ozone layer, and past GPS satellites, a massive anomaly is on the rise. For years, scientists have detected a subtle yet persistent flaw in Earth's magnetic field, a field we once thought was static. Now, it's not only expanding, but also splitting. And remarkably, it looms directly over South America and the South Atlantic. This isn't just a weak spot in our planetary shield, it's a literal gap. This phenomenon has caught NASA's eye and is far more than a mere scientific curiosity. It disrupts satellites, leads to failures in high-precision instruments, and compels engineers to devise ever more complex contingency plans. When Earth's magnetic shield falters, our planet is enveloped by a magnetic field, an invisible bubble that shields us from the relentless barrage of charged solar particles. Without this shield, we'd be vulnerable to dangerous radiation levels. It's thanks to this protective barrier that we enjoy a stable atmosphere, reliable satellite communications, and even the mesmerizing northern lights. But this field isn't a magical creation. It's generated by the movement of molten iron in Earth's outer core, thousands of kilometers beneath the surface. This process, known as a geodynamo, produces electrical currents that sustain our magnetic field. However, like many natural processes on Earth, it's not perfectly uniform. Several factors influence the stability of this field. One significant factor is a massive structure of dense rock, termed the African Large Low Shear Velocity Province, LLSVP, located beneath the African continent. This structure affects the field's generation so profoundly that combined with the natural tilt of Earth's magnetic axis, it results in a region with significantly reduced magnetic intensity. The South Atlantic Anomaly, a cosmic pothole. Enter the South Atlantic Anomaly, SAA, the focal point of our story. It's a vast expanse in the sky, stretching between South America and Southern Africa, where Earth's magnetic field is dramatically weaker than anywhere else. NASA often likens it to a pothole in the road, but in this case, the pothole is in the magnetic field itself. And this flat tire is expanding rapidly, which is why NASA is on high alert, fearing this anomaly could reach the US. How do we know this? When satellites traverse this region, they encounter a deluge of high-energy solar particles. This can cause equipment failures, sensor resets, and even complete data loss. The International Space Station, ISS, for instance, passes through the SAA on all its orbits. While astronauts are protected, external instruments like the GDI, which measures forest data, require extra precautions. And here's where it gets intriguing. Since 2020, scientists have observed the anomaly splitting into two distinct zones, each with its own center of minimum magnetic intensity. Observing the unseen, before it alters everything. Thankfully, NASA is closely monitoring the situation. Missions like ICON, GDI, SWARM, and others are tracking the SAA in real time. Additionally, historical data, such as that collected by the Sam Pitts mission, feed into predictive models that help engineer plan future missions and safeguard satellites. And this is the part most people miss. While the South Atlantic Anomaly doesn't directly impact life on Earth's surface, it underscores a profound truth. Our planet is dynamic and ever-changing, even in its deepest, most invisible systems. This phenomenon will remain a focal point for NASA, much like a galaxy we once overlooked and now see only as a black hole. But here's the thought-provoking question. How might this expanding anomaly influence our future space endeavors? And what precautions should we take now? Share your thoughts and opinions in the comments below. NASA warns, unraveling the South Atlantic Anomaly and satellite risks. Imagine Earth's protective shield has a growing dent in it, and we're flying our most expensive technology right through it every single day. This isn't science fiction. It's a reality known as the South Atlantic Anomaly, SAA, a massive, invisible weak spot in our planet's magnetic field that is expanding and baffling scientists. At its core, the South Atlantic Anomaly represents a fascinating and urgent intersection of deep Earth geology and our high-tech ambitions in space. This sprawling region of diminished magnetic intensity, stretching over South America and the southern Atlantic Ocean, creates a hazardous environment for the satellites and space missions we depend on. As this anomaly shifts and evolves in unpredictable ways, space agencies like NASA are in a constant race to understand its origins, track its movements, and mitigate the risks. Unraveling the secrets of the SAA is not just about protecting our orbital infrastructure. It's about peering deep into the heart of our planet to understand the very forces that make it a habitable world. Where does this anomaly come from? The origins of the South Atlantic Anomaly lie thousands of miles beneath our feet. The culprit is the geodynamo, the churning, swirling ocean of molten iron and nickel in Earth's outer core that generates our protective magnetic field. Think of it as a planetary-scale electric generator. However, this process isn't perfectly uniform. The SAA's existence is largely influenced by two key factors. First, the tilt of Earth's magnetic axis doesn't perfectly align with its rotational axis. Second, and this is the part most people miss, is the presence of a colossal, dense structure called the African Large Low Shear Velocity Province. This massive blob of rock, located about 1,800 miles down, disrupts the smooth flow of the liquid core beneath it, creating turbulence that weakens the magnetic field in the specific region above, leading to the anomaly we observe today. A high-tech headache in orbit.